Hey everybody, it's Mr. N, and we've got our next lesson here. This is on algebraic reasoning. So basically what we're going to do in this lesson is we're going to learn a little bit about proofs, and we're going to start by doing them algebraically. So we're going to do algebraic proofs, and you've seen these a little bit in the past in Algebra 1, but let's go over them again. So first of all, let's remind ourselves what a postulate is, and it's a definition. So it's something that can be taken to be true. We do not need to be proving it. Doesn't need to be proven. We just know it's true. We assume it's true, and math works because it's true. Theorem is a rule, but you have to prove it. So this is what we're going to work on. We're going to have theorems that we got to prove, but our theorems right now are just going to be algebraic equations. And then when I say prove, well, you have to develop a logical argument and then use a sequence of statements to prove a conjecture. So, in a proof, you have to provide a reason for each justification. So, what we're going to do is we are going to set up proofs, and I'm going to make statements. And for each statement I make, I am going to provide a reason. And this is called a T-chart for a proof. Right now we're just going to do the proofs as T-charts so that you can remember for every statement that you make, you give a reason. And usually the statement that you make, the very first one, is something that you are going to be given. And the reason would be because that's what you're given. So that's how this will work. Oh, let me erase this over here. So whatever statement that will go in here typically is something that you're given. So our algebraic one would be the equation. We're given that equation. Now, as we solve these, let's take a look. We need to remember some algebraic properties. Addition property of equality. This is the one that tells me if I add something to one side, I have to add the same thing to the other. Subtraction. If I subtract something from one side, subtract the other. Multiplication. If I multiply something, in this case C, by one side, I have to multiply the same exact thing, C, to the other side. Division. If I divide by C, here divide by C, assuming C doesn't equal 0. Now this one might seem weird with algebraic properties, reflexive A equals A, but when we do geometric properties and geometric proofs, this one will be important. Symmetric, if A equals B, then B equals A. This is now getting really technical in proofs, and I probably won't hold you accountable to that. And then we talked about transitive. We actually talked about it, how it's similar, how it's law of syllogism, and you already know this one. If A equals B and B equals C, then A equals C. And then substitution, where I could just substitute a number in for a variable. So here, if A equals B, and B can be substituted for A in any expression. Now, we can apply these geometrically, and these are the reflexive one right here. Let me show you. The reflexive, if segment EF, you would just say it's congruent to segment EF. So it's congruent to itself. Well, you ask, well, what does that have to do with anything? Well, suppose you've got a triangle right here, and this is your segment EF. But suppose you have a second triangle on the other side right there. That's also your segment EF. Well, this EF right here, and I'll put it in yellow, is part of two different triangles. And that's where the reflexive property will come into play. Again, here's that symmetric one, which I'm not going to hold you accountable to it too much, but technically in math we do need it. If angle 1 is congruent to angle 2, then angle 2 is congruent to angle 1, and it just lets you flip-flop it around so that you could say it either way. And then you've got the transitive property. Again, this is with segments. If segment PQ is congruent to RS and segment RS congruent to segment TU, then PQ would be congruent to TU. So from here to there, since these ones are the same. And then we know what the distributive property is for the sum and difference. A times B plus C would be AB plus AC, and A times B minus C, AB minus AC. Okay, taking a look here. Now we're going to do some examples. So let's take a look. We will do these student journal ones in class, but let's just do some of these examples here together. Okay, so if we have to state the property, If 80 equals the measure of angle A, then the measure of angle A equals 80. This one is the symmetric property. The next one, if RS equals TU and TU equals YP, then RS equals YP. This is transitive property. And yes, you could say of equality, and I'm just not, just because I'm just not, don't feel like writing it. Over here, if 7x equals 48, then x equals 4. What did you do to each side? You divided by 7. This would be the division property. And you could say of equality. Okay, over here, VR plus TY equals EN plus TY. VR would equal EN, because you subtracted a TY from each side. So this was subtraction property of equality. And then over here, the measure of angle 1 is 30, and the measure of angle 1 equals the measure of angle 2. That means the measure of angle 2 is 30. Okay, so if the measure of angle 1 is 30, and the measure of angle 1 equals the measure of angle 2, this is just substitution. Okay, this is just substitution. I'm substituting this in here instead. Okay, it's not transitive. This one is substitution. Now let's take a look at this proof. And this is going to be like our first algebraic proof. So let's just see how it goes. On this one, suppose you are given 8x minus 5 equals 2x plus 1. And you got to prove that the answer is x equals 1. Okay, so how are we going to do that? Well, again, for each statement I make, I have to provide a reason, and this is our T-chart. Okay, and I usually number them 1, 2, 3, but you can go A, B, C, D, E, F, G. I usually number them 1, 2, 3. So this first one is always going to be our given. We always start with what we are told, and that's the reason for it. It's a given. Step one will always be your given, okay? Some books also like to put the givens mixed in, but we're going to always put it at the top here. Now look at what I did here. 8x minus 5 minus 2x equals 2x plus 1 minus 2x. This was the subtraction property. I subtracted 2x from each side. Now, they're saying substitution here. You could just say simplify. I will let you get away in my class, but just by saying simplify, okay? And what do I do here? Well, I'm going to combine these, right? Combine like terms means to simplify. So this will be 6x minus 5 equals 1. Now, I'm going to say 6x minus 5 plus 5 equals 1 plus 5, and this is the addition property. Now, again, I will let you, in my classes, combine two steps into one so you don't have to write another simplification step right here and write simplify. You could just go, I can't spell simplify. I can't spell. Anyway, I would just let you go from here to here, right? 6x minus 5 equals 1. Then your next step would be 6x equals 6x, and you could just say subtraction property, addition property, whatever. In this case, it was the addition property. You added 5 to each side. So again, let me reiterate what I'm saying, is that you could have combined these two and just wrote addition property. You could have combined these two and just wrote subtraction property. I'm okay with that. So now you're dividing 6 by each side. So this will be our division property of equality. And then again, here you'll get x equals 1. And this was a simplification step. Simplify. And again, as I said before, if you wanted to combine these two as well, you can. So in this second proof, if I can combine anything just to save steps and save time, I will. So let's see. Let's see what we got. We've got if the measure of angle ABC plus CBD is equal to 90, the measure of angle ABC equals 3x minus 5, and the measure of angle x plus 1 over 2, the measure of angle CBD is x plus 1 over 2, then x equals 27. So this is really still, even though it's geometric, it's still an algebraic type proof. So I'm going to determine what my given is. Your given will be this if statement. So you're going to be given that the measure of angle ABC plus the measure of angle CBD equals 90. You are also given that the measure of angle ABC is equal to 3x minus 5. And you're also given that the measure of angle CBD equals x plus 1 over 2. What you have to prove is x equals 27. Okay? So that's all that was our givens up here. So I'm going to make my t-chart, and I'm going to put in my statements, and then I'm going to put in my reasons. And let's see what we got. And I told you, you're going to always start with, in some books, again, we'll put some of the givens in different spots, including the very first step. But I want you to put the given all here up here. The measure of angle ABC plus the measure of angle CBD is 90. The measure of angle ABC equals 3x minus 5. And the measure of angle CBD equals x plus 1 over 2. All of this is our given. Our first step is our given. So now let's see. I know that if I add these two, they told me I get 90. And they also told me that ABC is 3x minus 5. So let's put that in. So I'm going to say 3x minus 5. And look at what I did. I substituted this. Oops, let's choose a different color. Let's choose this one. I substituted that right in there. And they told me what CBD is. CBD was plus, oops, let's go back to the pen here, okay, and CBD was, so this is plus, x plus 1 over 2. And let me highlight what I did there. Here was CBD, CBD, and there's CBD. So I just substituted that in there. All of this equals, wow, I'm struggling with my pen today, equals 90. And all of this was a substitution step, so substitution property. So now let's continue solving this mathematical equation right here. So I can say there's more than one way to do this. I can choose to multiply everything by 2 to get rid of the fraction. So let's go ahead and do that. I'm going to multiply everything by 2, and I'll get 6x minus 10 plus x plus 1 equals 180. Look at what I did again. Let me write it down for you here. I multiplied everything by 2. And this was just the multiplication property of equality. I did skip a step. What step did I skip? I skipped a distribution step, right? I could have over here put in the distribution as well. I could have said 2 right here. If you did that, that's fantastic. You could say 2 times the 3x minus 5 plus the x plus 1 over 2 equals 90 times 2. Write it as the multiplication property, and over here you'll write this one as a distribution property. I'll take either answer. So I kind of combined it in one and just said, okay, I multiplied it all by 2. Okay, next step. Now I'm going to do some simplification. I'm going to say 7x, right here, combining like terms, minus 9 equals 180, and this is simplify, okay? You could say combine like terms. And now I'm going to add 9 to each side, right? So I'll get 7x equals 189, and this was the addition property. And then my last reason, I'm going to divide both sides by 7, and I'll get x equals 27. And this was the division property. So do you see how I skipped a couple steps, whereas up here, when they did this, they showed it to you. And I called this thing where they give you the t-chart, they give you some things here and there and you have to fill in the blanks. I call this a skeleton proof. We're going to do mainly skeleton proofs at first until you get used to it, the first few proofs that we do, and then I'll have you start doing these T-charts all on your own where you have to set up the given and the prove and do it all. But again, right here, I did skip a couple steps right in here, whereas in this one, they added those steps. All right, but it's okay. I'll take either way. This is going to be a little difficult, so we're going to have to do several of these. So in class, we'll do a few more. So thanks for watching. Make sure you hit that like and subscribe button, and I'll see you guys in the next video.